Section 6.4, Inverses of Matrices. We're going to learn in this section how to find an inverse for a square matrix. We call square matrix. Square matrix means 2 by 2, 3 by 3, 4 by 4 matrices. How do we find the inverse of a matrix? So let A, starting with this, let A be a matrix. Let A be a matrix. A to the negative 1 be the inverse of matrix A. That's just a notation. Doesn't mean it's 1 over A, just a notation to denote for the inverse of a matrix. We recall and introduce the identity matrix I, which is 1 0 0 1. So the entries on the main diagonal are all ones. So this is called I sub 2 by 2 matrix. So that's 2 by 2 identity matrix. We can have 3 by 3 identity matrix, 1 0 0 0 1 0 0 0 1. So that's called I 3 by 3 matrix. So the entries on the main diagonal are all ones. By definition, what is the definition of an inverse matrix? The inverse of an n by n matrix A is an n by n matrix A inverse if it exists, so that A inverse is I and A inverse times A is also I. So we define A inverse is really the inverse of A. If I multiply them pairwise, A inverse or A inverse A, both of them should give us the identity matrix. And let's look at an example on this. Find AB and BA. So AB means A times B and B times A if matrix A is 3 1 5 2 and matrix B 2 negative 5 negative 1 3. These are two matrices. We're going to multiply them as we learned in the previous section. A times B or AB 3 1 5 2 multiplied with 2 negative 1 negative 5 3. So how do we multiply? If you remember, we multiply row by column, row by column. So the first row by the first column. Multiply the 3 by 2 plus 5 by negative 1. So 3 by 2, so it's going to be like this. It's a 2 by 2 matrix. 3 by 2, 6 minus 5. Same row with the next column. 3 by negative 5, negative 15. And 5 by 3 is 15. So I'm done with the first row. Next row, 1 times 2, 2. 2 minus 1, 2. 1 times 5, negative 5. 2 by 3, 6. And that would give us 1 0 0 1. It gives me the identity matrix. So I'm going to try to multiply backwards like the B times A now. B times A, matrix A times matrix B times matrix A, 2 negative 5, negative 1 3 times 3 5 1 2. I'm going to multiply it the same way as we multiplied the previous one. Row by column. 2 times 3 6 minus 5. 10 minus 10. Next row by the first column, Negative 1 by 3 is negative 3, and 3 by 1 is 3. Now the last row by the last column, negative 5 plus 6. If we combine them, 6 minus 5 is 1. This is 0, this is 0, and this is 1. Also give me the identity matrix. Since we can say, we draw a conclusion here, A times B I get I, and B times A also I, then A and B are inverses of each other. So you can say A is the inverse of B, or B is the inverse of A. Quick notes to add. First note, it is not always true that A times B has to equal to B times A, or equals to I. So you can multiply A, B, get the identity, but B times A is not the identity. Or you can get two different things. They don't have to be both identity. So we can say here it is not always true that AB equals BA. Not all the time. Third note, if a matrix has an inverse, not all matrices have inverses. If a matrix has an inverse, then it is called invertible. So for mathematics to keep saying matrix A has an inverse, they just say it has an inverse. It is invertible. So they don't have to keep saying it has an inverse, They just say given matrix A that is invertible means it has an inverse. So can we look at how they can ask us a question about inverse matrices? Maybe they can ask us, are the matrices, they give us two matrices, M, 1/2, -1, 3, -12, are the matrices this and N inverses? So they're not asking us yet to find the inverse of a matrix. They're just asking us if they are inverses of each other or not. So how do we do this? We try to multiply M times N. 1/2, 3, -1, -12 times 4, 1, 2, 1. We need to multiply them and verify if Mn equals I, like the identity matrix, and Nm equals I or not. So we're going to multiply row by column. Let's see what that's going to give us. I put these boxes to organize the work. So 1/2 times 4, 1/2 times 4 is 2. -1 times 1 is -1. Same row by the next column. 1/2 times 2 is 1, and -1 by 1 is -1. Next row by the first column. 3 times 4 is 12. -12 times 1 is -12. 3 times 2 is 6. -12 by 1 is -12. This gives me 1, 0, 0, 0, -6. So notice I'm going to highlight this. This is not 1, 0, 0, 1. So this is not the identity matrix. Do I have to check N times M? No, because it fails one of them. It doesn't work out. So then we can say that M and N are not inverses of each other. They're not inverses of each other. Now the question is how to find the inverse for here in this section we focus on the 2 by 2 matrix, how to find the inverse for 2 by 2, not 2 times 2, 2 by 2 matrix, if exists. Not all 2 by 2 matrices have inverses. Well, let's say I'm going to show you the operation, how the operation works here. Let's say if a square matrix A is given, then this is what we do. We write the matrix A here. We put the components or the elements of the matrix in here, slash, and the identity matrix 1 0 0 1. We are going to do some row operations as we did in the previous sections. Row operations to turn this to look like the identity matrix here. So 1 0 0 1, and we will get another matrix B there with the operations. That matrix B, is going to be the inverse of matrix A. In other words, we can say B is symbol wise is A inverse, like that. So of course with an example things will look much easier than that, but this is the kind of like the process or the procedure to find the inverse of a matrix. Let matrix A with elements 1 4 3 8 find A inverse. So find the inverse of this. If they say find the inverse, means it exists, it has an inverse. So the procedure from before, it says you take the matrix A and write the 2 by 2 inverse, 2 by 2 identity matrix next to it. And what we're going to do here, we're going to do some operations, row operations on this. Okay, row operations. So how is that going to work? So the first step in this, what are we going to do? I'm going to turn this part here into 1 0 0 1. So I already have one there. So that one is there. So right there, I don't have to worry about it. So we do clean column by column. If you remember from before, clean column by column means I'm going to make this first number here 1, which is already 1. Now I look at the first column, I need to make that 3 to be 0. To do so, we need to multiply row 1 by 3, negative 3, and add it to row 2. Add it to row 2. So row 1 stays the same, 4, and then we have a 1 and 0. So that stays the same. We don't modify anything in there. Now we're going to multiply the first row 1 by negative 3. That's negative 3. Add it to 3, that's a 0. Now negative 3 times 4, that's a negative 12. So I multiply by this 4. Add it to 8. That becomes negative 4. Negative 3 times this one, negative 3. Add it to 0 is negative 3. Negative 3 times 0, 0. Add it to 1, 1. So I cleaned the first column. I was able to get that column to be 1, 0. Now I look at the next column. This column here. That's the second column. I want to make sure that I can get this now to be 1. How do I get that to be 1? Well, the only way here to do this is multiply row 2, multiply row 2 by negative 1/4 and add it to row, just keep it like as is. We're not going to add it. Just multiply row 2 and just keep it in row 2. So row 1 stays the same. We don't change anything in row 1. Negative 1/4 by 0, 0. Negative 1/4 by negative 4 is 1. Negative 1/4 by negative 3 is 3/4. Negative 1/4 by 1 is negative 1/4. Okay, now the next step, I'm still on the same column. I want to clean this and make it 0. How do I get that to be 0? I need to multiply row 2 by negative 4 and add it to row 1. So let's see what happened. So negative 4 times 0 is 0, plus 1, 1. Negative 4 times 1 is negative 4. Added to the other 4 is 0. Negative 4 times 3/4, like this. You got negative 3. Added to 1 is negative 2. Negative 4 times negative 1/4. You get a 1. Added to the 0, it's 1. And the second row stays the same. So now 1, 0, 0, 1 stays the same. And what we got here, this matrix that we got, that's A inverse. That's the inverse of that matrix. Negative 2, 1, 3/4, negative 1/4. This matrix is the inverse for the given matrix. And we can check that one out. To check that one out, how do we check this? We multiply the given matrix by the one we just obtained. The given matrix was 1, 4, 3, 8. And the inverse of that, negative 2, 3/4, 1, and negative 1/4. What do we get for this? Row by column. This row by column. Negative 2, let me write it here, negative 2. 4 times 3/4 is 1, it's 3. Same row by the next column. 1 times 1, 1. 4 times negative 1/4 is negative 1. 3 times 2 is 6. 8 times 3/4, so 3/4 times 8. By 4, 1, by 4, 2. 2 times 3 is 6. 3 times 1 is 3. 8 times negative 1/4, that's a minus 2. Let's see what we get. That gives us 1, 0, 0, 1. So it worked. See, it worked. So let's try the other way. A inverse A. That's not enough. You must do also A inverse times A. So A inverse, the one we got was negative 2, 3/4. And we have 1, negative 1/4. And multiplying this by matrix A, which is 1, 4, 3, 1, 4, 3, 8. So that gives us row by column, row by column. Negative 2 times 1, negative 2, plus 1 times 3, 3. So negative 2 plus 3. Same row by the next column. Negative 2 by 4 is negative 8. 1 times 8, 8. Next row by this column. 3/4 times 1, 3/4. Negative 1/4 times 3 is negative 3/4. Next one. 3/4 times 3 is 4. Negative 1/4 times 8 is minus 2. That gives us 1, 0, 0, 1. See, it worked as well. So both of them give me the identity matrix. So that confirms that the answer we got is really a correct answer. Let's look at another example. Find A inverse if A is 1, 1, 2, 3. So how are we going to find this? The same procedure. So we're going to follow exactly the same procedure. Clean column by column. So first we write the matrix A 1, 1, 2, 3. And then 1, 0, 0, 1. What are we going to do with this one? I already have this as a 1. That's called pivot number. So I'm going to take that row 1 multiplied by negative and add it to row 2. So that's 1, 0. Keep this the same. 1, 0. Negative 2 plus 3 is 1. Negative 1. 0 plus 1, 1. So that's 1, 0. Looks good. 1, 0 looks good. Now we have this as a 1. That makes us easy to work with the problem, not a lot of work. Now we take that second row multiplied by negative 2 and add it to row 1. 1, 0, 1. So negative 2 by this one here is negative 2. Added to that 2 becomes 0. Negative 2 by negative 1 is 2. Plus 1 is 3. Negative 2 by 1, negative 2. Plus 0, negative 2. And keep the next row the same. So notice this is the identity matrix, and therefore that's the inverse. That's the one we're looking for. So the inverse matrix we're looking for is 3, negative 1, negative 2, 1. The next thing is Why learning inverse matrices? How can we use them? Well, we use inverse matrices to solve system of equations. In two or more variables. And to do that, let's introduce a theorem. So the theorem said, if a system of n linear equations in n variables has a unique solution, then the solution is given by x equals A inverse times B. A inverse times B, where A is the matrix of coefficients, B is the matrix of constants, and we'll see what that means, and X is the matrix of variables. So let's see how to do that. Solve the system of equations using inverse matrices. So this is the system: x plus 4y equals 5, 3x plus 8y equals 7. So what are the matrices here? A, B, and X. What are they? So remember, A, we define matrix A is the matrix of coefficients. So what are the coefficients here? For X we have 1, 3. For the Y is 4, 8. The next matrix, B, is the constants. Is the matrix of constants. So B is the constants, the 5, 7. Those are the constants. And X is the variables. So the matrix for the variables, X and Y. So X, we need to solve for X. It's A inverse times B. I have B, but I don't have A inverse. So what do we need to do here? We need to find the inverse of matrix A first. So we first find A inverse, and then we multiply that out. So 1, 4, so we take 1, 3, 4, 8, 1, 0, 0, 1, that's the matrix, and then multiply row 1 by negative 3 added to row 2, 1, 4, 1, 0, negative 3 by 1, negative 3 added to 3 is 0, negative 3 by 4, negative 12, added to 8 is negative 4, negative 3 by 1, negative 3, added to 0 is negative 3, negative 3 by 0 added to 1 is 1. So far we have 1, 4, 0, negative 4. So the first column is cleaned. Now we need to clean the next one. Always we need to make this one. How do I make that one? The only way is to multiply it by negative 1/4, row 2, and the result will go into row 2. So row 1, no changes on row 1. Keep row 1 the same. Negative 1/4 by 0 is 0. Negative 1/4 by negative 4 is 1. Negative 1/4 by negative 3 is 3/4. Negative 1/4 by 1 is negative 1/4. So now I have a 1 there. I'm going to use this one to clean this up, make it 0. How do I get that? I multiply row 2 by negative 4 and add it to row 1. 1, 0 stays the same. Negative 4 by 1, negative 4. Added to that, that's a 0. So the 1 stays. Negative 4 times 3/4, that's a negative 3. Added to 1 is negative 2. Row 2 stays the same. Negative 4 by negative 1/4, that's a positive 1. Added to the 0 is 1. And this stays the same. Note, when you write the stuff down, this row is the one that stays the same. It never changes. So row 2 stays the same. If you look back at all the operations that we've performed today, in all the examples, that row always stays the same. If it's row 1 or row 2, it stays the same. It doesn't change at all. So what we're going to do now, this is the inverse. That's A inverse. So we need x. X is A inverse times B. Remember, x has components, x, y. A inverse, negative 2, 1, 3/4, and negative 1/4, times matrix B, which was 5, 7, is the matrix of constants. Now keep the left-hand side the same. Here we're going to multiply row by column. When we multiply them, what do we get? Negative 2 by 5, negative 10. 1 by 7, 7. So that gives me negative 3. Next row, this row by the second column. 3 over 4 times 5. And there's a minus 1/4 times 7. So 15 over 4 minus 7 over 4. That gives me 8 over 4, which is 2. So from here, you can see that x should equal to negative 3 and y should equal to 2. That's what we're looking for. You might be saying for now, like, wait, why do I have to do all this work? Just so you know, for 2 by 2, of course, like if you use elimination, substitution, that's easy. Either elimination or substitution is much easier than using matrices. But the reason we use matrices, it helps us when we advance, when you go into a more advanced level in mathematics, you see 3 equations in 3 unknowns, or 4 or 5. When you hit that number of equations, elimination becomes way more difficult and tedious. Matrices will organize, arrange everything for us. It will make all the steps more organized. No matter how many equations we have, you will be able to solve the system using matrices.